Let's take a look at a quick example highlighting that last point we talked about in the previous video about the minimum circuit size for a given frequency. So we're told that an RF circuit is going to be operating with signal frequencies of 100 megahertz, 300 megahertz, and 500 megahertz. Assuming that the signals travel at 0.9 C, what is the largest size the circuit should be to minimize radiation effects? Okay, so first of all, let's figure out exactly what that 0.9 C is. So of course, we're just going to plug in the value for our speed of light, which is approximately 3 times 10 to the 8th meters per second. And we see that this is 2.7 times 10 to the 8th meters per second. So this is how fast our signals are traveling in whatever medium it is they're traveling through. So we're assuming it's a non-dispersive medium, but now it's no longer a vacuum. Okay, so we have these 3 different frequencies. So we have different signals depending on what our circuit's doing, but we know that it's going to be operating at one of these 3 frequencies. And we know that in general, that our circuit size should be 5% of our shortest lambda. So we'll call that lambda sub shortest. So which one of these is going to correspond to our shortest lambda is the question. And so of course, as we saw last time, because our lambda is equal to C, well, let me keep that more general and say this is our velocity u over our frequency, we can see that higher frequencies are going to correspond to shorter lambdas. So we're going to focus on this highest frequency of 500 megahertz. So we can say that our lambda shortest, so I'm just going to, so our lambda sub shortest is equal to our speed, which is 2.7 times 10 to the 8th. So that was our 0.9 times the speed of light, divided by our frequency, which is 500 times 10 to the 6th. And so remember, units of hertz is per second. And so we get the seconds canceling out, and we're left with 0.54 meters. So a little over half a meter. But remember, we're looking for 5% of that shortest wavelength should be the biggest size in our circuit. So of course, we just do 0.05 times this 0.54. And what we get is 0.027 meters. And so what that means is, in order to minimize our radiation, we want our circuit to be smaller than 27 millimeters. So to minimize our radiation effects, our circuit should be smaller than 27 millimeters, which is also 2.7 centimeters. So we can see how for a relatively, well, it is a large frequency, but we're still in the megahertz range. And of course, there are several things that operate in gigahertz and above. So relatively, we're still kind of mid-range for high frequencies. And so even then, we see that our circuit should be smaller than 27 millimeters to limit our electromagnetic radiation. So pretty small size, and that just gets smaller as we increase our frequency.